Hello, good morning. Welcome to this lecture for power engineering. So there's going to be two lectures, and then we're going to start looking at some problems. And that'll finish my part of the syllabus, the lectures anyway. And then in a few weeks' time, you have a different lecturer actually who will take you for generators and machines. So today we're going to look at some tests to determine the equivalent circuit. So hopefully you can recall that last week we looked at how we generate the equivalent circuit, and what we want to do is determine the values of the components. And the first test we want to look at is so-called open circuit test. So that's where we get the secondary and we have no load across it. And from this, as we'll see, we can determine Xm, Rc, and the turns ratio. So Np over Ns. So we can simplify that equivalent circuit. Because we have no current going through the secondary, we can simplify the circuit to this. So we just have the magnetizing current and the losses due to the core, hysteresis and eddy current losses. And so with the open circuit test, we can measure primary voltage, primary current, and we measure the primary real power, and also we can measure the open circuit voltage. So we measure the voltage between here and here. So the thing to note is the real power is associated with Rc, and reactive power with Xm. If you realise that, then you can find Rc from Vp squared over the primary real power, and we can find the apparent power by multiplying Vp and Ip. So then, if you recall, we can have our power triangle. So this is our Sp, this is our R, the primary real power, and this then will be Qp. So we can find Qp from Pythagoras, and then once we've found Qp, we can find Xm. Okay, so we've found these two components now, and we can find the turns ratio by measuring Vp and the open circuit voltage, VSOC. Okay, so we found these things. What we want to do now is find these things here. So we can do this with the short circuit test. Why can we do that? Because this I1 is much greater than the current that flows through here. So I call that I2. I can say I1 much greater than I2. Okay? So because of that, I can modify the equivalent circuit to this. And I can measure in the short circuit test the voltage of the primary, the current Ip, which is equal to I1, and the power, the real power. And again, the real power is associated with this, and the reactive power associated with this. So I can find the R1 equivalent by dividing the primary power by the current squared. I can find the apparent power by VPIP. I can then consider my power triangle. Using Pythagoras, I can then find this X1 equivalent. And if I know this reactance, I can also find the inductance if I know the frequency. Okay, so by doing short circuit and open circuit tests, I can find all the components for the equivalent circuit. So here's an example which we can have a look at. So we do our open circuit test and we measure these values. We do our short circuit test, we measure these values. The reason we like these tests for is because actually the currents to do the tests are quite low. Okay. So here, for example, in the open circuit test, you just need really the magnetizing current. And similar to the short circuit test, the current that's drawn is really dependent upon the values of those inductance and resistance values. So they're much smaller than you will have in practice. So the currents are quite small. It's one of the reasons why we like to do these tests. Anyway, so we can find the value of the equivalent circuit by putting those formulas in that we saw earlier. So I think you can probably do this in your own time. Okay, so hopefully if you do that, you can compare with the solutions here. Hopefully these solutions are all correct. Okay, and so again, I put these slides onto Moodle, or you can just really look at the video and make sure you get these results. I don't think, if you have any problems obviously getting them, please let me know. Quite happy to discuss with you. So, yes, if you've got any questions, please try and make me aware of any questions that you have. Quite happy to try and answer them. Okay, and that completes this first part of the lecture. Thank you for your attention.